Hi everyone. So we are going to start our second session of the morning on sea level rise and the impact of sea level rise on Egypt and the Nile Delta and the nearby regions. So first, I would like to introduce Florence Colleoni. She's a researcher on paleoclimate and she's working in Italy. And she's also a representative of SCAR, which is a committee in charge of monitoring the Antarctic Peninsula and all the Antarctic area. So, welcome, Florence, and the floor is yours.
Hello, everyone. So we thought that after presenting a bit about the basis of ice sheet dynamics this morning, we could try to have a focus on impacts, for example, in Egypt, because as you know, low-lying areas like Delta are the first areas that are vulnerable to sea level rise. So I will present a few facts about sea level rise in the future and give you a paleo perspective. It's a very brief presentation, and then Pam Pearson will make the case for Egypt. So I'm sure you have or not, I don't know, but seen this figure tons of time now. This is from the summary for policymakers from the last IPCC report, and this is showing you the sea level projections by the end of the 21st century for the different scenarios, the different emission scenarios, okay, from SSP 1.9, which corresponds to the Paris Agreement, which meets the target of limiting global warming by below 1.5 degrees, to the SSP 8.5, which is the, let's say, worst case scenario that goes up as plus 4 degrees of global warming, okay? So as you can see, I mean, those scenarios a bit diverge, but I would say that between the SSP 1.9 and SSP 8.5, which is the brown curve, the sea level rise is different from, let's say, varies from zero point 0.5 meter, at least I think 44 centimeter, to 77 centimeter in the worst case scenario by the end of the 21st century, with an upper limit of uncertainty reaching about 1 meter of global mean sea level rise by the end of the 21st century. So as you can see, all the bench of scenarios keep sea level rise by the end of the 21st century below 1 meter, okay? 1 meter is already a lot, because if you think about what I've been doing 20 centimeters over the past century to most of low-lying coastlands and small islands, the Pacific state, you can imagine that 1 meter, it's kind of a lot. Even half meter, it's a lot, because the main impacts of sea level is not only rise, but it's also taking into account high tides, flooding, okay, and then also storm surge damage. So the higher the global mean sea level is, and the larger the area are impacted by storm surges and high tide floodings. On this figure, you also see a curve that is the dotted line, okay? This dotted line represents the lack of knowledge that we have about Antarctic processes, okay? Most of this dotted line you see goes well above 1 meter by the end of the 21st century, because it accounts for the unstable behavior that some part of Antarctica has in response to oceanic warming. In fact, in Antarctica, some of the sectors have the base, their foots, the ice, grounded below sea level. So it's highly vulnerable to all the oceanic warmth that is advected by climate dynamics toward the coast of Antarctica. What is the main effects is that the warmth is melting the marine termination of glaciers of Antarctica that are floatings. It has the impact is that it thins those parts and it disintegrates them. Those parts are really important because they act as a tap for the inland flow. Okay, so they limit the discharge from ice flow into the ocean, and thus they regulate a bit the rate of sea level rise and Antarctic contribution to sea level rise. So those parts, when they disintegrate in a runaway process. So they start disintegrating, and they disintegrate until a new equilibrium in the stability of the ice flow is reached. Okay, because of that, we know that large portion of Antarctica are highly vulnerable to this kind of processes, and especially oceanic warming. So if we take plus 4 degrees of global mean air temperature, it also raises ocean temperature by a lot, and a lot amount of heat is uptaken into the ocean, which means that most of the Antarctic margins are vulnerable to this kind of unstable behavior. So this dotted line represents what the ice sheet community has been modeling in terms of instability of Antarctica if it were to occur because of this oceanic warming a bit everywhere. So this dotted line has been kept by IPCC in the report because it cannot be ruled out. This kind of unstable behavior cannot be ruled out because we also observed it in the past. The thing is, most of the cryosphere responds also on a very long time scale, and the end of the 21st century is already at the corner. So if we want to have a real perspective on how the cryosphere, the potential of the cryosphere to meet global mean sea level rise, we have to look beyond the 21st century, okay? Because no global climate warming will not stop at the end of the 21st century. So if we have a look at what happened at 2300, the projection of IPCC goes up to 6 meters, and still with the dotted line, we are reaching more than 15 meters, okay? And you will tell me, oh, wow, it looks like a lot. This looks like a bit unrealistic, probably. But as I say, I'm a paleoclimate modeler, okay? And if we look back in the past to the different past one periods and the reconstructed global mean sea level rise, then we can understand that it's not the case. So this was during the very one period in the past, okay, where only Antarctica was existing at that time. Global mean temperature was 5 to 9 degrees higher than today, and CO2 was larger than 500 ppm in the atmosphere. Reconstructed sea level rise led to a 20 to 30 meter sea level rise above present day level, okay, because most of Antarctica disintegrated at that time. And we know that because this is based on geological records. We found them around Antarctica, so we are absolutely sure that this happened. Another period that occurred 3 million years ago has global mean temperature higher by 2 to 4 degrees with a CO2 level above 400 ppm, okay? And this led to a sea level rise about 15 to 20 meters, okay? And same thing here. We have the geological records in front of the Antarctic sector that disintegrated to show us that this really happened. Next period is a period a bit closer to us, was a period that was warmer than today, but not as much as the past two periods, only 0.5 to 1.5 degrees warmer than today. So this is the target of the Paris Agreement. And this led to a 15 meter in average sea level rise with a great disintegration of Greenland and Antarctica as well. We have a CO2 that is in the range of 300 to 400 ppm. So that's nowadays, basically. Then another interglacial, the closest to us, the last that occurred in the past. Same thing, temperature range plus 0.5 degrees to 1.5 degrees of global warming, but CO2 below 300 ppm. Nevertheless, sea level rise was about 5 to 10 meters, with a large part of Antarctica also contributing to it. We also have data to show that, but at that time, also Greenland actually really contributed to it. So this is what the paleo data show us. Now, if I put our projection of the worst case scenario, that the one I showed you before for 2300, and I put it in this paleo perspective, you can see that the range that we project for 2300 with a global warming of plus 4 degrees and CO2 well above 500 ppm, okay, definitely shows you a sea level rise that could reach 15 meters, around 10 meters of sea level rise. And then looking at this picture, you can definitely understand that it's definitely not unrealistic, okay? This is largely in the range of what the natural variability of the system has been showing us for the past 20 million years, okay, in terms of Antarctic destabilization and contribution to sea level rise. That's why our scenario, even the worst case scenarios, and the dotted line on the IPCC projection that I showed at the beginning is definitely not a scenario that we can rule out. This is completely realistic. This might really happen. So this is what I had to say. Now I let my colleague proceed on that. Thanks.
Great. Thank you, Florence. We have question at the end of all the reward presentation. And now I would like to introduce Pam Pearson, which is director of ICCI, so in charge of this pavilion. And she will talk to you about more in detail how the sea level will affect Egypt and the region around. Pam?
Thank you so much, Hugo. So we thought that, in concert with this COP really, and especially with the release of the State of the Cryosphere report, it's important to talk about what this means for Egypt. Adaptation in particular is one of the most important issues being addressed here, as well as loss and damage. And so I thought it would be interesting then, in the context of what Flo has just presented, to talk about what this might mean for Egypt and the population here, and how we as, civil society or negotiators or scientists can best context this. And so we see this as a bit of a dialogue. So this is a figure that I have taken from Dr. Julie Brigham Greta, UMass Amherst, who is one of Flo's colleagues in terms of having a paleo impact. And just again, to reiterate how extreme where we are right now is, right? If you look at the past 3 million years, CO2 between glacials and interglacials went between 180 and 280 and 180 and 280. That's what you're seeing here, okay? So that was the pattern of the Earth until we humans came along. And this is where we are now, right? It's way off the charts. And so that's why we're seeing this rapid warming. That's why we're seeing these changes in Antarctica and the Arctic on Greenland and in mountain glaciers, all contributing to sea level rise. And we can't forget ocean warming, right? Because the warming ocean expands. But at this point, the ice sheets have pretty much taken over. Greenland and Antarctica together are more than land glaciers and more than ocean warming. And increasingly, the ice sheets are going to be what's going to dominate. So that's why we're focusing on them right now, because that's what we're looking at this point in time. And there's really no analog that we're aware of in Earth's past that shows this kind of rapid rise in CO2 and rapid rise in temperature. So we are quite literally off the charts. There we go. And so this is a real simple summary of what temperatures have meant in the past. Again, as Flo's last slide showed, there's a lot of variation in this. There are times when we've had surprisingly high sea levels, even below 1 degree. But these are the figures that we're trying to sort of make people aware of as, in general, what we're looking at least over time. 1 degree, 2 to 3 meters higher than today. Okay, we're already above that. Over time, 1.5 degrees, we're looking at 6 to 9 meters. And so this is why most cryosphere scientists will say that 1.5 degrees should not be considered a safe temperature over time, because if we stay there for any length of time, then we're committing ourselves to 6 to 9 meters. The uncertainty that you hear scientists talk about is in the rate and when. If we reach 1.5 and bounce off it like a guardrail, which is the way Jim Skay, one of the IPCC vice chairs, puts it, we bounce off, we come back down again. Can we prevent that 6 to 9 meters, or is it immediately committed? We really don't know the answer to that. I think most cryosphere scientists would both say, we don't know, it's highly uncertain. But they would also say that, probably if we stay at 1.5 degrees for longer than 200 or 300 years, then we're looking at committing this. And there's some evidence that the West Antarctic Ice Sheet could have tipped as early. There are some scientists who say it tipped already at 0.8 degrees. Okay, so we're already committed to the 3 to 4 meters that would come from, say, Thwaites in particular and other parts of the West Antarctic Ice Sheet, and that we may not be able to stop that. We might be able to slow it. But these are the kinds of things that we're looking at. These are the kinds of risks that we're taking by continuing to essentially pour CO2 into the atmosphere and cause temperatures to rise. We're not allowing temperatures to rise, we're causing them temperatures to rise. And I think that kind of language is important, because it's actually a decision we jointly as a human community are making. So then if we look at Egypt, this is 1 meter of sea level rise. We know that we're committed to this. I think that virtually all cryosphere scientists have said we're going to reach this definitely by the end of this century, maybe sooner. And as you can see, it makes Alexandria essentially an island because you get backfill in on the delta. But we could reach this by 2100. That's 3 meters. Certainly with high emissions, as Flo said, it is within the realm of the possible. We've seen it happen. The question is, could it happen by 2100? But if you put together, West Antarctica, Greenland, land glaciers, what we know is happening, for example, with high emissions, we'll lose an awful lot of the rest of our land glaciers. That's almost half a meter right there. And if you put it all together, that's why, scientists can say this is definitely not out of the realm of the possible. This is 6 meters. And now we're looking at where we might be as early as 2150 if some of the newest projections combining modeling and paleo research, we could reach this level by 2150. So this is the time of our great-grandchildren could be dealing with levels like this in the Nile Delta. And keep in mind also that it's very flat, right? You're going to get saltwater incursion. And this is the real breadbasket, of course, of Egypt. And so it doesn't mean, this is where the water would be at 6 meters. But the salt water that would come in under the land and make it unusable, at least by any technology we have today, for the kind of crops that Egypt has right now. And I don't know if the rest of you have enjoyed as I have, because this is my first visit to Egypt, the fruits. There's just so much great produce and food here that is all locally produced. Most of it actually without pesticides because the land is so fertile. And having that disappear would be a tremendous blow to this country. And of course, people are going to have to move. They're going to be displaced. And these are tens of millions of people just in this area. But this is what we're looking at 10 meters, which again, some of this newer research says we could reach by 2300. And in essence, you have the Mediterranean reaching Cairo. And we could end up committing ourselves to this by continued high emissions of CO2 already right now. So this is kind of the reality facing just one part of the planet, Egypt. And if you could now show the YouTube video, because there are attempts to deal with this. And to me, this is really revealing, but I'll just, show you this video. It's very short, just about 2.5 minutes. And then, we can discuss how this level of adaptation is going to be adequate or not, what we need to be thinking about in terms of Egypt's adaptation, limits to adaptation, and really, taking that out to other parts of the world, because I think we have a lot of people here from different countries today. So if you could play the video, please. And this is a project being supported by the Green Climate Fund.
One of the main breakthroughs over the past few years has been the realization that climate change, biodiversity loss, inequality, food insecurity were different dimensions of the same crisis. Here we are protecting the Nile Delta against the existing sea level rise. But with climate change, this phenomenon will continue. There are elements which are truly extraordinary in this project. The first thing is that we are speaking about ecosystem-based approaches. Rather than a concrete dam, we have basically used the power of nature to protect populations and natural resources. So it's much more cost-effective. But in addition, it's something that is living, an evolutive organic solution which is built on the knowledge of local population.
How many engineers in the world have the modesty and the empathy to be able to start by asking the local population, how would you do it? I'm full of admiration.
And actually, visiting this site has filled me with a sense of wonder. There is nothing that's replaced the opportunity to discuss with the ultimate beneficiaries directly. So it's a wonderful example in this project. We are leveraging the power of nature, the knowledge we have acquired in terms of ecosystem management to avert catastrophic climate change.
All right, so this is an existing project, and when I look at this as someone who's also worked in development, I see a lot of really good things here. It's very locally based. It's working with the local people. It is involving, you saw a very brief glimpse of it here, but it's involving women to build these kinds of fences that then capture sand and make sort of natural berms against sea level rise. So a lot of good things, but at the same time, if I click back, well, you saw those pictures. That's okay. We don't need to bring them up again. You know, when you see those pictures, the idea that this could stand for any length of time against what we're, you know, potentially facing, it really is a kind of Band-Aid. And one of the things that is being discussed increasingly, both here, but also mentioned quite a bit in the IPCC 6 assessment, the working group too, is that we're facing limits of adaptation. And of course, these kinds of nature-based solutions in terms of holding the sand back, you know, I actually come originally from Texas. I've lived on the Gulf Coast. I've been through a lot of hurricanes. One storm can wipe out things like this. You know, you see it happen. There are actual cities in the Gulf Coast of Texas that nobody's even heard of right now that used to sort of be the Houstons of Texas. Has anyone here heard of Indianola? Yeah, okay. Indianola on the Gulf Coast, it was wiped out by 2 back-to-back hurricanes with about 12 years apart. It was the major port on the Gulf Coast of Texas. If you go down now, you see a graveyard that they've managed to preserve, a very small graveyard. It's in the middle of a few sand dunes surrounded by water, and that's all that's left of Indianola. And the reason Houston exists is because Galveston was wiped out, of course, in 1906, in essence. You know, it's now a beach place, but again, it was a port, it was the main city, and the population relocated from Galveston to Houston on a swamp. And the joke among Houstonians, ironically, of course, sort of the world capital in many ways of the oil industry, is a single Category 5 hurricane that goes up the Houston ship channel from the Gulf Coast northwest into Houston would pretty much wipe out the city. And we've already seen something similar to that just from flooding from a tropical depression, really, that just parked over Houston for many days and rained down. So, you know, I guess that's sort of my question. And we can go to Q&A right now. You know, what are reasonable limits of adaptation? How do we bring together mitigation and adaptation? How do we take the reality of what I showed and the continued rise in CO2 and be honest with people while not scaring them, but at the same time, not holding back that this is the reality that we're facing. And so there are a lot of dilemmas here in terms of, you know, what do we spend our adaptation money on? What do we spend our mitigation money on? And how do we compensate the inevitable loss and damage? We're sort of, you know, people joke we need to walk and chew gum at the same time. It's like we need to walk, chew gum, and juggle all at the same time. And it's a really, really hard task in front of us. So I think we should open this up for questions or almost, you know, back and forth discussion. So happy to take comments, questions together with Flo and open it up.
Do someone has questions to Pam or Florence? Or a comment? Okay, so I might ask you a question, Pam. How do you think Egypt will face sea level rise? Like, do you know of any large cooperation to face sea level rise in the Nile Delta?
To my knowledge, this Green Climate Fund project right now is the only one. And again, I don't know, you know, this could maybe deal with 0.5 meter, I would guess, or 1 meter of sea level rise. But again, things, you know, the other thing with sea level rise, of course, it's not like a gentle rise in a bathtub, right? You do have the background, it's almost like background, and then you have storms and you have tides. And so again, looking at this, I could see some of this being wiped out by a really bad storm, and our climate seems to be providing us with much more extreme weather. And so the question is how long this would last. I live now in Sweden in a place that is actually below sea level. And there they've built 7-meter-high berms to protect the heart of the city because of those kinds of events. And that probably, that is a 2100 project, they think. So it will protect the city for about 100 years. And then after that, they're not sure.
Yes. The IPCC reports and forecasts are forecasts of scientists. And when you have a scientist saying that sea level will rise and such, etc., and there is some consensus, this is a tool for decision makers to act on. You are not a scientist. You're a diplomat. So the question is, how can decision makers trust, okay, a diplomat saying those things? I think that it's very difficult to do something that is going out of the scope of the scientific consensus, that is delivered again and again in the IPCC reports. So this is the intent of those reports, was to be the base for decisions. It's very difficult, we don't like those that say no, IPCC is all prejudiced, etc. And the same thing, we should not disregard it from the other side. Say it's not telling the whole truth. I feel uncomfortable as coming from science to discuss scenarios not by some group of scientists.
That's an easy question, actually. This is from groups of scientists. All of this that you've seen is in the IPCC report. And it's the dotted line, for example, that Flo showed. So we rely very much on IPCC scientists. The State of the Cryosphere report, the majority of the reviewers are IPCC scientists. So there's actually, we're sort of putting it in policymaker language, being diplomats, knowing what diplomats can listen to, but there's a that's why with these kinds of events, we always begin with a scientist to talk about it. So, again, these are extremes. The other thing we can do with this kind of a report, which the IPCC cannot do, is keep up with the latest science. So one of the reasons we felt comfortable highlighting some of these extremes is because of 2 papers that came out in August that kind of supported the dotted line. And I would say, unfortunately, supported the dotted line. And the reason the IPCC chose to put that dotted line in there was because it was based on just 2 studies, but they were very well-respected studies, actually by IPCC scientists as the lead authors. And so they felt it was important to let policymakers know that even though if you take the bulk of papers published from 1995 all the way to when they closed, many of them based on models that are their sort of global system, and so they don't look specifically at Antarctic dynamics, like some of what Flo showed and that you'll see later today, that these newer studies, even though naturally there are only fewer of them, might be more correct than the studies that have come before, because we're getting better at this. And what was really telling for me about these later studies is that they calibrated them with Earth's past. So, you run the model backwards. Does it predict what we know happened in Earth's past? And then you calibrate it over the past 30 years back, where we've had really, reasonably good observations. And then you run it forward and see what it says. And that's what these latest models and papers, the 2 that came out this past year, have essentially done. Flo, it looks like you want to say something too.
Well, actually, I would say compared to all we know about paleoclimate, it's a bit provocative what I'm about to say, but the IPCC report is highly conservative. So we are also working with IPCC in general to broaden a bit the horizon to paleoclimate knowledge that we have, to include it in the reports, actually, because it's also a matter of discussion and agreement on what to include in the report or not. So what I see as a paleoclimate person, because I've always been a paleoclimate person, I'm not doing the projections myself, but all those events really happened. They happen fast, and they happen with a very high amplitude anyway. So what we're trying to do as a paleoclimate community is provide ground evidence for future scenarios, and just to say, okay, the trajectory of emission that is projected is definitely not unrealistic. It's highly realistic, right? But IPCC is highly conservative, and sometimes including some catastrophic scenarios that would sound catastrophic to many of the people here that are not scientists, sometimes seems a bit sensitive and difficult to really accept, which I can completely understand. But from a pragmatic point of view, this is what I see in the data. So we should not ignore it just because we are afraid of it. I think that's perhaps not productive.
Great, thanks. Does someone has another question or comment about what the discussion we just had? Great. So thank you, everyone. And we'll close this session, and feel free to come by and ask us questions later if you want.